All right, here's an example for you. Let's calculate the covariance and the correlation coefficient rho for this joint discrete distribution. Here it is, okay? So up along the top, I've got the possible values for x, and down along the side here, I have the possible values of y. This is a joint discrete distribution, right? X and y are both discrete random variables. The probability that x is 1 and y is 2 at the same time is 10%. The probability that x is 1 and y is 4 is 10%. Okay? The chance that x is 2 and y is 2 at the same time is 30%. Okay? And so, in fact, I know that these numbers need to all sum up to 100%, right? 1, 2, 3, 4, 5 plus 5 is 10 divided by 10 for the decimal. Yeah, that's good. Excellent. So, let's see. This number should be 0.3. This number should be 0.6. This number should be what? Huh? What? That's right, 0.1. Very good. This is the marginal distribution for x, because it occurs in the margin, right? For the random variable x, okay? Along here, I could have the marginal distribution for y. Okay, 0.1 plus 0.3 plus 0 is 0.4. 0.1 plus 0.2 plus 0 is 0.3, and 0.1 plus 0.1 plus 0.1 is 0.3. If I add these up, I better get 100%. And if I add these up, I better get 100%, right? Very good. Yeah, so, alrighty. Now, what I want to do is calculate the covariance first, and then I'll go and get the correlation coefficient, because the correlation coefficient requires the covariance. So to get the covariance, I'm going to use that theorem that little baby theorem that we proved last time. I'm going to first get the mean of x, the mean of y, and the mean of x times y. Okay, and then I'll be ready. I need to get those three things. All right. So to get the mean of x, I can just appeal to the marginal distribution for it, right? I don't need y stuff. I've got the marginal distribution here for x. So what's the probability that x is 1? It's 0.3. So the expected value of x is 1 times 0.3 plus, let's see, it can be 2 with probability 0.6. Or it can be 3 with probability, that's right, 0.1. So 0.3 plus 1.2 is 1.5 plus 0.3 is 1.8, right? Good. What is the expected value of y? Oh, I'm glad you asked. It's 2 times 0.4, right? Y is 2 with probability 0.4. Or it can be 4 with probability 0.3. Or it can be 5 with probability 0.3. I think this comes out to be 3.5. See, this is 0.8. This is, let's see, give you 2, 3.5. Yeah, okay. Finally, I want to get the expected value of x times y. For this, I'm going to have information about how x and y behave together. So I can't use the marginals. I'm going to have to use their joint distribution, right? Well, what kind of products can you have for the two variables? Well, I could have 1 times 2, and I could have 2 times 2, and I could have 3 times 2. I could have 1 times 4, and 2 times 4, and 3 times 4. I could have the product 1 times 5, and 2 times 5, and 3 times 5. and these are the probabilities. See? So let's do this. I'm going to have 9 terms, I think. 1 times 2, right? And that occurs with probability 0.1. 1 times 2 times 0.1 plus 2 times 2, 2 times 2 with probability 0.3, right? Or 3 times 2 with probability 0. Or 1 times 4 with probability 0.1. Or 2 times 4 with probability 0.2. Or 3 times 4 with probability 0. Or 1 times 5 with probability 0.1, or 2 times 5, probability 0.1, or 3 times 5 with probability 0.1, right? And I think if you do all this, you should get 6.4.